Do I have anybody from Iceland here who wants to argue with me about that? Technically, geysers got their name from a geyser in Iceland called Geysir. So you could argue that that's maybe more famous. I would say that this geyser back here that gets, you know, about whatever 90% of 3.8 million people is watching it every year is probably the most famous geyser in the world. We get about 3.8 million visitors a year here. 90% of them will stop to see Old Faithful, which is amazing because what are those other 10% of the people doing that they're not, you know, during their trip to Yellowstone, at least popping their heads in here to watch an eruption of this thing. And I say that, yes, a lot of people have seen it and a lot of people come and watch it, but it really is an incredibly special geyser. And I think that can go over a lot of people's heads too, especially if you're the type there's so much to see at Yellowstone. You know, you're, okay, I gotta go watch Old Faithful, I don't have time to hang out and see too much else because we gotta get to the canyon, we gotta go look for animals up in the Lamar Valley. There's a lot to do in this park. And so people might see Old Faithful, and it is a great representation of what a geyser is, but it is in fact one of the strangest geysers we have. And the reason for that is, so I'll start with some numbers. We've got about 300 to 500 active geysers here in the park, depending on who you ask, depending on how you define a geyser. There's actually some gray areas. 300 to 500 active geysers. If you count every single little thing that's ever just gone spoop, 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 following an earthquake or something like that, it's closer to about 1,200 geysers, things that have ever geysed in the park. So we've got a lot of geysers here in the park. And Old Faithful, just here in this upper geyser basin, we've got more than 150. Guys, stay on the boardwalk, please. Guys, you guys need to stay on the boardwalk. There we go. Good. It's a danger of hot water. We'll be coming out here shortly. So Old Faithful is just one of those 150 geysers out here. But for those of you who came through the visitor center, how many of those geysers do we predict? 6 out of the at least 300 active geysers are predictable. So it is indeed a very rare thing to actually be able to predict a geyser at all. And up, split cone. Not a predictable geyser. So congratulations. You're getting to see one of the special ones here. Split cone goes a lot less often than Old Faithful, but that's really all it does. It is adorable. It's got a Facebook page you can like and everything. So it's got some contributions. It's got about 200 friends on Facebook, so it's a little, it could be a little better off. But the predictable geysers are the exception rather than the rule. And for those of you who came through here and actually looked at those predictions in there, you noticed Old Faithful plus or minus 10 minutes. That is really good. The rest of them are plus or minus at least a half an hour. Something like Grand Geyser plus or minus 90 minutes. Great Fountain Geyser plus or minus 2 hours. Our criteria for being able to predict a geyser is that we've got to be able to get it right 90% of the time with our prediction time and the window. So for it to be able to be predicted with 90% accuracy plus or minus 10 minutes is incredible. The really incredible thing is that it's been that way for 140 years, since the park was established. That's the real miracle. And to understand that, you got to know a little bit about how geysers work. So, start with the basics. We are right here, Old Faithful. Talking a little bit about it before I got started here. What's the black line? The caldera. Sorry about that. What is a caldera?
Dormant volcano.
Massive volcano, yeah. It's a little hard to put into words. What it basically is if you picture about 640,000 years ago, everything in here in this black line would have been a big giant dome. The ground would have been all lifted up because there would have been a huge ball of magma underneath it. And 640,000 years ago, that magma, about 240 cubic miles, got spewed out, covered 2/3 of the country in ash, and you got left with about a 35 by 40 mile crater. Now, you don't feel like you're in a crater, right?
Sorry.
You can't really actually see the caldera, can't get a great view of the caldera from anywhere because it has since been filled in by all these hills we see around us, all these subsequent lava flows. The last one being about 80,000 years ago. And that's really important because that puts us just the right distance from that magma. Where we're now at a point where if you were to go straight down from here and just drill straight into the earth, at about 4 miles you would hit the actual molten rock itself. You'd hit it about 4 miles down, not very far away, right? So it's kind of an unsettling feeling, and indeed, kind of an unsettled place. It's about, goes for hundreds of miles in all directions, goes down hundreds of miles, across hundreds of miles, shifting back and forth, this liquid rock, kind of rocking, swelling, shrinking. How do we experience that up here?
Earthquakes.
Earthquakes. Makes us the most earthquake-prone area away from the coast in the United States. So we get anywhere from 1,000 to 3,000 earthquakes a year here in the park. Most of them you won't feel. Even on like June 3rd, we had about a dozen of them, about 17 miles north of Norris Geyser Basin. We didn't feel any of them down here. That's the norm, is we get lots of these small earthquakes. We don't feel it, but they make a difference. In all this volcanic rock around us, that little bits of shaking and jostling from those earthquakes will create cracks. And those cracks are what makes geysers and hot springs. So you have, just like anywhere else on Earth, you have water falling down as rain, snow melt, or whatever, trickling down through this kind of porous rock and gathering in what's called the water table. About 700 feet below us, all the water's sitting there in basically like a reservoir and getting heated up because it's very close to that magma to about 420 degrees or more. So really, really, really crazy hot. And that heat is also going to create convective currents. So you've got the water sitting down there. These convective currents will then push the water up in these cracks. So you get it pushed up here. As it gets pushed up, it cools. Being a very relative term, cools off from that 420 degrees. And as it cools, it's really hot down there low, hot enough to actually dissolve some of this volcanic rock and take on some of the mineral, that siliceous sinter. Same stuff I'm talking about all over. It gets on your glasses. And it will deposit that during an eruption up here on the surface. But as it works its way towards the surface and is cooling off, we'll deposit it on the inside of those cracks. Now, the big difference between a geyser and a hot spring. Hot spring is just anywhere you've got a heat source and that water gets heated up and moved up to the surface. And that we've got about 10,000 plus thermal features in here. Most of them are hot springs. In a geyser, something really special is happening. That's somewhere along the way in that plumbing system, that silica being deposited is going over a little bump or something and creating a constriction. And that constriction is what makes a geyser, essentially. So on a hot spring, that heat is able to be dissipated relatively evenly while the water is boiling or just kind of bubbling, or you see the steam coming off of it. That heat's getting dissipated evenly. It's not building up. In a geyser, you have this constriction. So what I'm showing you guys is Old Faithful. There's actually a diagram of Old Faithful. We got a good look at it because a geologist in 1993 took a super heat-tolerant camera right after an eruption and sent it down on a plumb bob to be able to look at what was going on the inside. We found about 25 feet down, you hit this constriction. 25 feet. What's that going to feel like if you dive 25 feet down underwater? Hurts, right? So you've got about 25 feet down, you've got a lot of pressure being applied below that constriction. And that makes a big difference here. So this water below that constriction is getting heated up. It's not able to dissipate that heat. Saw lots of geysers. We saw Beehive Geyser, which goes maybe once a day, anywhere from 8 to 25 hours between eruptions. They saw Castle Geyser, they saw Grand Geyser. They actually happened to be here on one of the days that Giantess Geyser was erupting. They were here for a day and a half. The very first time any formal expedition came here. They happened to catch Giantess Geyser, which goes maybe twice a year. So they were incredibly lucky, but they literally had no foundation of knowledge to even be able to appreciate just how lucky that was. But they noticed that Old Faithful went off 9 times. And they said that's how they ended up giving it the name Old Faithful. You fast forward now to 2014, that's still the case, and we still call it Old Faithful. But that is absolutely
There you go.
That's the
No. That's the foreplay.
yeah.
I was going to just finish by saying no eruption is guaranteed, so do appreciate each one. Don't take it for granted, but you're about to, so I'm going to get out of the way. This one's pretty much guaranteed.
Maybe. We don't know. There it goes. Hurry up, you're missing it.
Not much of a contrast
So,
with the sky.
Folks, take your pictures. You need your 2 feet or a butt on the boardwalk. Thank you. Sorry.
Don't touch my knees. The water runs off this way.
See what happens?
Forward.
Teamwork!
Right.
I get away with stuff like that.
She knows that by now. We've seen a lot of, you know, the thermal points, so she knows that everything's spewing out of the ground is hot.
Move that hand. Move that hand.
Very solid.
That hand. Move that hand.